Have you ever stopped to think about what's really going on inside an AI when you type something in? You know, how does it actually go from just a bunch of letters on a screen to understanding what you mean? Well, today we're diving into some incredible new research that might just completely change how AI learns to read, and maybe, just maybe, how it learns to think.
And really, it all comes down to this one question. It sounds simple, right? But the answer is the key to unlocking the next wave of artificial intelligence. To really get why this new development is such a big deal, we've got to first take a look at the old way of doing things. So, for a long time, most AIs have used this thing called tokenization. Just imagine it's like a special dictionary that's decided on ahead of time. Before the AI even begins to learn, it's handed this fixed dictionary that chops up all of human language into little pieces called tokens. These could be words or even just parts of words. And that's it. That's how the AI sees your sentences.
But here's the catch, and it's a big one. This method has a huge limitation. Think about trying to navigate our world today with a dictionary from, say, the 1800s. You'd be totally lost, right? Missing all the new words, the slang, the nuance. Well, for an AI, it's pretty much the same problem.
And this really gets to the heart of the issue with these fixed dictionaries. The research paper we're looking at today just nails it. It says that once that dictionary is picked, the model is stuck with that choice. It's a decision made on day one, and it can never, ever be changed.
Let's just compare that to how you and I read. We're flexible. We pick up new words, we understand slang, we get the context of a conversation. But traditional AI reading, which often uses a method called Byte Pair Encoding, or BPE, it's completely rigid. It's stuck with that static vocabulary, so it really struggles with new ideas or rare words, and it can totally miss the subtle meaning behind what you're saying. It's locked in.
So what's the real consequence here? This fixed granularity, as the paper calls it, basically freezes the model's potential right from the start. It puts a hard ceiling on how smart the AI can get, all because its very first step, how it sees words, is so inflexible.
Okay, so if that's the problem, what's the solution? Well, this is where it gets exciting. Researchers have come up with a totally new approach. It's a complete flip of the script. Instead of just giving the AI a dictionary, you teach it how to build its own language from the ground up.
This right here is the game-changing idea. What if we just stopped handing the AI a rulebook for language? What if, starting with nothing, it could learn to group letters into words and then words into ideas, all by itself, adapting and growing as it learns more?
So how in the world does this actually work? The technical name is an autoregressive U-Net. I know, that sounds complicated, but stick with me, because the idea behind it is actually incredibly elegant. It just builds understanding one layer at a time, going from the tiny bits of information all the way up to complex ideas.
All right, let's walk through it. It starts at the absolute bottom, with raw bytes. We're talking individual letters here. It learns that T, H, and E belong together to make the word the. Then, the next layer up takes those words and groups them into phrases, like the black cat. And finally, the highest level puts it all together and grasps the actual idea, the concept of a domestic cat. It's a true bottom-up process, building from bytes all the way to ideas.
The paper puts this beautifully. You can think of it like this. The early, lower layers are focused on the nitty-gritty details like spelling and basic grammar, and that frees up the deeper, more advanced layers to focus only on the big picture stuff, the actual meaning, or what the researchers call the broader semantic patterns.
Okay, so that's the how. But what about the why? What's the real payoff for taking this new, flexible approach? Well, it turns out the benefits are pretty massive. First of all, since the AI is learning its own dictionary, that whole process is now baked right into the model itself, which makes it way more adaptable. This also means it gets really good at things like spelling and grammar. But here's a huge one. It's much better at sharing what it learns across different languages, which is a game changer for languages that don't have a ton of data online. And on top of all that, the performance results are looking really, really good. And when you look at the numbers, this is where it gets fascinating. The old BPE method, that's our baseline, and it's strong. A simple version of this new U-Net method is already right there with it, totally competitive. But here's the kicker. When they made the U-Net deeper, adding more layers, the performance shows this clear, promising trend shooting upwards. It suggests this new approach has so much more room to grow and could eventually blow the old methods out of the water.
So let's zoom out. What does all of this mean for the future? We're not just talking about a small technical update here. This could be a fundamental shift in how we approach building artificial intelligence.
What we're really witnessing is a move away from spoon-feeding an AI a fixed, human-made rulebook for language.
We're shifting towards creating models that can develop their own flexible, nuanced, and self-taught understanding of the world, starting from the absolute basics.
And that leaves us with one last, kind of mind-blowing question to think about. For us, language is the foundation of thought, right? It's the operating system for our brains. So if we teach an AI to understand language in a more fluid, dynamic, and natural way, are we also, maybe accidentally, giving it the tools to think in ways that are more flexible, more nuanced, and perhaps even more creative? The answer to that could redefine everything we think is possible.